about well-formed formulas under logic. Now, in our previous lecture, we have already understood what are truth functional connectives. There are four major truth functional connectives. We'll just have a quick glance on it again. So that is and, or, if then, and if and only if. And besides this, there is one more, which is negation. When I say it is cloudy and I say it is not cloudy, so it is not cloudy is a negation of the preposition that I have. Now when I am using the words and or, and is a conjunction. There are other conjunctions as well. For example, important ones are but, I have however and although. But in logic, these three are less commonly heard of. The most common conjunction that we use is and. Okay, so and is the most common conjunction. Similarly, under disjunction we have or. There is one more, another interesting disjunction, which is unless. Again, it is less commonly heard of. Or is the most common disjunction that we use. Now these four are the most important basis for a well-formed formula. Now when we are trying to understand the basics for the formulas in logic, it's very interesting. First of all, we denote it with a capital letter. The negation should always be as a prefix. So when I say A implies it is raining, okay. Now this is a preposition. If I want to say negation of A, then the tilde should be before A. So it should be as a prefix. Tilde sign should be as a prefix, and then I can say it is not raining. Okay. Now there are another forms, the truth functional connectives, the four of those, which is the first one here is and, the second one is or, the third one is if then, and the fourth one is if and only if. Now these truth functionals can occur, listen carefully, can occur only and only when there are two capital letters on either side. So there is A, there is B, in between I can put or, and I can put the symbol for if then, I can put the symbol for if and only if. But this would occur only and only between two capital letters. Now let's go to certain examples. So we'll have an example which is a correct form of logic formula, which is an incorrect form of logic formula. So the first example is it is raining. So let me keep the example the same so it makes sense. So I write it as it is raining. Okay, so this is A, that is a correct formula. It is in capital letters, and based on the first rule, the capital letter, this is correct. The second one is again correct, which says it is not raining. Why? It is correct because I am putting a tilde sign which is before the capital letter. It is a prefix. So be very careful. It is a prefix and therefore is correct. Then when I put two tilde signs, that means negation of negation, that means truth. Okay. So that is again correct. Then I have negation of A and B. Dot represents and. So I have a kind of simple preposition that is saying it is not raining and it is cloudy. Okay, so this is how my A implies it is raining, B implies it is cloudy. We'll keep the example the same in the incorrect ones as well, so that there is no confusion. Okay, now this is A and this is B. So inverse of A, the negation of A and the B statement within the parenthesis or the brackets, then it is a completely a correct logic formula. Okay, the next one is the same statement before this statement. Now this is an example of a compound preposition. So before this statement, I am connecting it to an if then statement. So before this I write if it is raining and it is cloudy, then I am saying not of C. Okay, so then I say it is not I can say twilight, or I can put in any other example. I can put it as sunny or any other phrase that I'm trying to put up here. But the idea is I'm putting a negation of C, and that is a correct formula, a correct representation. Why? Based on the third rule. The third rule was between the two capital letters there should be the truth functional connective that should be there. So here in the first case it is and, in the second case there is if then, and the negation sign is before the capital letter, so it is a prefix. So again it is correct and everything is within the right parenthesis. So the first parenthesis is for this and the second parenthesis is for this. And the same happens for the last one where I am trying to take a negation of everything. Okay, but let's move to some incorrect formulas. Now this is an incorrect one. The first one is incorrect. Why? Because this negation sign should be as a prefix, not as a suffix. So this is incorrect. If I write a small a, then again it is incorrect because I should write capital letters. Then I am writing only a and it is in a parenthesis. It is incorrect. I can put parenthesis only and only when there are connectives and there are two prepositions that are taken into account. For a single preposition, I do not put a parenthesis, so this is incorrect. When I am putting a and then I am putting a dot, that means a and, but there is no second term. So this is again an incorrect logic formula. There should be a second term. So I can write as a dot b. That would be a correct representation of it. Okay, so this is incorrect. The fourth one is incorrect because there is missing parenthesis. Now the first parenthesis is complete. A and B. Okay, it is rainy and it is cloudy. So that is within the parenthesis. But this whole if then is not within the parenthesis. So there should be another parenthesis that should be there. So one bracket is missing here. And therefore it is incorrect logical formula. The last one is again incorrect because I cannot put two truth functionals without a term. So I am putting and also, I am putting if then also, and there is only there is just two terms, and within each of the term, if it was a dot b and then if then c, then it would have been right. Okay, but there are just two terms and two connectives. That's not possible. So this is again an incorrect formula. Not this one. This one is an incorrect formula. So this is a lecture to understand the right usage of logic formulas, because there would be a lot of places where we would be using logic formulas further and creating truth tables. So if you are not sure about it here, you would face further issues as we move forward with the logic lectures. So this is a very important and crucial part of understanding the basics of logic. We would be coming up with very simple versions and interesting examples for logic. Stay tuned. Have a wonderful day ahead.